Okay, now we are at the next page of your notes. Alright, so we are on to the second type of algebraic fractions. Now, to simplify such algebraic fractions, it will require you to do factorization. Okay, either in the numerator or in the denominator, or both. Alright, let's look at example A. Example A, we can see that in the numerator, 14m squared minus 18m. Alright, this can be factorized on top. Okay, so if we factorize the top, between 14 and 18, common factor is 2. Another common factor is m. Alright, we factorize out 2m from both terms, 14m squared and minus 18m. So we will be left with 7m minus 9. Okay, how to check if your factorization is correct? Alright, you can multiply 2m back into both terms in the bracket to see if you get back the original expression in the question. In the denominator, alright, it will remain as 4m. So after factorizing, alright, it's much easier for us to identify how we can simplify the terms on top and below. Alright, between m and m, of course, we can cancel it away, and 2 and 4. So in the denominator, we will be left with 2. Alright, so answer for A, we will get 7m minus 9 over 2. Okay, now for the next example B, how can we simplify this with using factorization? So on top, between 7p squared and 28, right? We know that 28 is 7 times 4. Okay, so we can factorize out 7. You're left with p squared minus 4. And in the denominator, between p squared and plus 2p, p is the common factor. It will be left with p plus 2. Alright, once we reach this step, alright, you will realize, top and bottom, there's nothing to cancel. Okay, but if you can recall your algebraic identities, 7p squared minus 4, alright, this one is a form of identities, a squared minus b squared. Alright, 4 is your b squared, which is 2 squared, you will get 4. Okay, so we can further factorize the top to get 7 p minus 2 p plus 2, and in the denominator can't be further factorized, so remain as p plus 2. Okay, and now we can see that p plus 2 on top and p plus 2 below, they are common factors, so we can cancel it. And this one, we will be left with the answer 7 p minus 2 over p. Alright, so this is our answer for example B. Okay, in summary, if you were to perform factorization well enough, alright, you'll be able to do and handle such questions with confidence. Factorization had been gone through. There are in general 4 types of factorization: taking out common factor, which is what you have learned in Sec 1, factorization by grouping, and then factorization by special formula, and also cross method factorization. Alright, so for type 2 and 3 listed here, it is actually covered inside your notes number 7. Okay, you may need to take some time to revise if you have no idea what are all these. Okay, let me continue with the next example. Now, take some time to look at the questions below, okay, and the steps that is being shown, alright, to see if they are wrong or correct. If they are wrong, you can provide the correct solution in the space provided. Okay, for example A, let's look at the working. Okay, for numerator between 4a squared plus 6a, we can factorize out a. Okay, and after factorizing, in the numerator and denominator, a is a common factor, we can cancel off a. And after this step, what we are left with 4a plus 6 divided by 2a bc. Okay, and look at what the solution here. Between 4a plus 6, okay, we cannot, this step here is actually wrong. We cannot cancel 4 and 2. Before you cancel any term, you've got to make sure that it is being factorized between the two terms on top. So between 4a plus 6, okay, from this step onwards, between 4a plus 6, common factor is 2. We factorize out 2, and we have bracket 2a plus 3. In the denominator, we'll be left with ABC. Not really ABC. We'll be left with 2BC. Okay, because we have cancelled out A in the previous step, which is correct. So now, after this step, 2 and 2 we can cancel off. Okay, and the answer to this question will be 2A plus 3 over BC. Okay, now let's look at the next example. 4x minus 16 divided by 4x minus x squared. Okay, as explained in this step, in part A, we cannot cancel off 4a and 2 like this without factorizing the numerator. Okay, between the two numbers, the two terms on top, we need to factorize a common factor before we can cancel. So straight away this example B, okay, from the first step it is wrong. Okay, so how do we do example B? Okay, in the numerator, between 4x minus 16, we have 4x minus x. Okay, we can factorize out 4, then we have 4 bracket x minus 4. Okay, and in the denominator, x is a common factor, we can factorize out x. So we'll be left with 4 minus x in the bracket. Alright, and this one, if you remember our notes number 7, there's a portion where you can switch the two terms inside the bracket. Okay, and if we factorize out negative 1, so I can factorize out negative 1, and x minus 4 will switch position. Okay, to become 4 minus x. And in the denominator, you will see that between 4 minus x and 4 minus x we can cancel off. So the answer for this question will be negative 4 over x. Alright. On to the last 3 example. In example 3, so if you look at A is a very big fraction. Alright, if you see a very big fraction, just look at the numerator, try to factorize it, and denominator, try to factorize it. In the numerator, we can factorize out 10x squared from the two terms on top. Okay, and we'll be left with 10x squared bracket 2a plus 3b. In the denominator, it is a typical expression that you can factorize by grouping. So between the first two terms of 10ax and 8ay, we factorize out 2a. It is a common factor. So we left with bracket 5x plus 4y. And for the last two terms, 15bx plus 2by, we factorize out 3b. And we will be left with 5x plus 4y in the bracket. Okay, so if we compare the denominator now, at this step, 5x plus 4y, we can factorize out the whole bracket. Okay, and then we'll be left with 2a plus 3b bracket, and then 5x plus 4y bracket. So after this step, you will see that numerator 2a plus 3b and 2a plus 3b, they are common factor. Okay, so now we are left with a simplified form of this fraction, 10x squared over 5x plus 4y. Alright, and for example B, okay, in the numerator we have a quadratic expression. We can factorize it using cross method factorization. Okay, cross method factorization. And then in the denominator, 3x squared minus 12, we factorize out 3 from both terms to be 3 bracket x squared minus 4. Now x squared minus 4 is a special identity, which is a squared minus b squared, because 4 is actually 2 to the power of 2. Okay, 2 squared. 4 is 2 square. Okay, which is your b square. And if you look at the next step working, okay, numerator remains the same after cross-method factorization. You get 3x plus 2 times x plus 2, and denominator further factorized become 3 times x minus 2 times x plus 2. So now we have x plus 2 on the numerator and the denominator to cancel off. So the solution here will be 3x plus 2 divided by 3 bracket x minus 2. Okay, there's no need to expand out the denominator here. Okay, usually we leave it in the factorized form to show that there's no other factors on top that can be cancelled off in our answer, to show that this is the most simplified fraction. Okay, for example C, alright, 25 minus p squared. 25 minus p squared, 25 is 5 square. So 5 square minus p square, we have a square minus b square here again. Alright, and in the denominator we can factorize out 3. Okay, so we use special identity to factorize 5 square minus p square. We'll go and get the next step. Okay, and in this step you realize in the numerator we have 5 minus p, and denominator we have p minus 5. Okay, so in order to simplify this fraction, okay, we have to factorize out negative 1 from 5 minus p, either on top or in p minus 5 below. Okay, in my solution I do by factorizing on top. So I factorize out negative, and the p and 5, alright, they switch position, become p minus 5. So we can cancel off p minus 5 and p minus 5 to get our answer negative 5 plus p over 3. Okay, that's the end for this section on 6.1.